Hi, we'll be getting started with our second talk for this session. I'm introducing Brian McDonald. Brian is currently an assistant professor in the Department of Math at the United States Military Academy at West Point. He received his bachelor's in electrical engineering from Lafayette College, a master's of arts, and a PhD in mathematics from Johns Hopkins University. His research interests include using math, statistics, network science for the purposes of player evaluation and decision-making in sports, specifically in hockey. His talk today will introduce a new model he has created to better predict goals. So please join me in welcoming Brian.
Thank you. First of all, I'd like to thank, the organizers for organizing all this stuff and doing all the work that they had to do to get ready for the conference. I've helped organize a very, very small conference before, so I can only imagine how much work went into organizing this one. And also, thank you for having me, and thank you all for coming to listen to this talk. And so we're going to be talking about expected goals model for evaluating NHL players and teams. All right, so we'll start talking about some sort of things that people are currently using to evaluate performance of players and teams. We'll talk about the expected goals stuff that I've been working on, how we can use those things in adjusted plus minus, and then I'll take questions at the end. All right, so first thing, why do we need advanced statistics in hockey? I thought I'd start with that. It's probably similar answers in most sports, but let's just talk about hockey for a second. So probably using multiple seasons of data, I would say goals are probably the best thing to look at as far as evaluating team performance. But for smaller chunks of games, I would say that there's other things that are better indicators of performance than simply looking at goals. All right? And so this is the point of the talk, is the goal of the talk, no pun intended, is that we want to look for the statistics that are the best indicators of performance, future performance. All right? Some people in the audience have already heard my bad jokes, so I had to throw in a couple additional ones to make them laugh, or laugh at me or with me at different points during this talk. So, all right, so just a few notes for this work. We're considering only 5-on-5 situations, so even strength situations, where both goalies are on the ice, so no empty net situations. And we're using, every time I talk about a statistic, it's a per 60-minute rate statistic. So when I say goals, what I mean is the whole long phrase, goals per 60 minutes during 5-on-5 situations when both goalies are on the ice. All right, and I'll say the same thing for shots, Fenwick, and everything else I say. It's going to be the same thing. All right. So here's quantifying kind of what I said before with as far as goals is concerned. So what I mentioned before is goals are not always the best indicator of performance. If you're using smaller chunks of games, smaller than multiple seasons worth of games. All right. So if we were to take a look at, we'll take a team and split their season into two halves, and take a look at their goal scoring rate in one half and their goal scoring rate in the other half, and just look at the correlation between those two. We get a correlation of 0.2. That's the first number up there, which isn't very high. So it seems that goal scoring rate is not very consistent from one half of a season to another. If we remove 4 outliers, so by the way, I'm doing this for, I said take a team and split the season into two halves. We'll do that for all 30 teams, and also do it for each of the past 4 seasons. So we got 30 teams, we got 4 seasons. This is 120 data points. And we're taking the correlation. So if we move 4 of those 120 data points, we do a little better. There was 4 that I identified as extreme outliers, just extreme differences in goal scoring rate in one half and goal scoring rate in the other half. And so I removed 4 of those. The correlation was 0.34, which is an improvement. It's still not that great, but it is an improvement. So what if we were to take a look at some other stats? So we said goals aren't that great. If we have smaller chunks of games, goals are not the best indicator of performance. What if we took a look at shots, and we took a team's shots in one half of the season, and their goals in the other half of the season, and find the correlation? Just find the correlation. So you get a little bit better. So this suggests, I mean, it's pretty close actually, but it suggests that shots can be used to indicate as an indicator of performance. All right? And it's a little bit better than goals. It's definitely better than goals when you don't remove the 4 outliers. It's a little bit better than goals when you do remove the 4 outliers. And by the way, when I say splitting the season into 2 halves, I actually don't mean first half and second half. I mean, I split the season into odd and even games. So I didn't want to do first half, second half, because I thought maybe mid-season trades and injuries and stuff like that would have an impact on second half performance or something like that. So I split it into odd and even games. All right. So what are some alternatives? So we said shots were a little bit better than goals. What are some alternatives? So one thing you could do is look at shot quality or weighted shots. And so the idea here is that not all shots are created equal. And we have detailed information about shots, like distance, angle, whether or not the shot was a rebound shot. So these kinds of things can be used to evaluate how good a shot is, according to some model. So in other words, you could take a shot and estimate the probability that that shot will become a goal based on the detailed information about that shot. And so several people have worked on this. Michael Shuckers at last year's Sloan Conference came up with his Digger rating, his defense independent goaltender rating, where he did exactly that. In order to come up with that rating, he needed to estimate the probability that a particular shot would become a goal. And similar things have been done by some other folks using different methods. Michael Shuckers used non-parametric regression. Some of these other folks used logistic regression. So that's what Ken Kraswicki did. He has several papers on the topic, and before him, Graham Johns and Alan Ryder also talked about the idea of shot quality and weighting shots based on how good of a shot it was. And I along with 2 colleagues, Craig Lennon and Rod Sturdivant, we're working on our own model right now. So that's one alternative. So another alternative is Fenwick and Corsi, and we need to talk about some definitions before talking about those probably. So let's talk about a couple definitions. First of all, shot. This is a shot on goal, which means either the goalie saved it or it went in. And this has to be a puck directed towards the net that would have gone in had the goalie not stopped it in order to count for a save. All right? If the puck goes 3 feet wide and the goalie snags it with his glove hand, that doesn't count as a shot on goal. No, it's not supposed to. It might get recorded that way because it's kind of hard to tell probably, but according to the definition, that's not a shot. So a missed shot, so a miss is an attempted shot that missed the net high or wide or hit the post. So a post is not a shot on goal. And blocked, by that we mean the opposing team's forward defenseman blocked the shot. Someone other than the goalie blocked the shot. All right? So by Fenwick, we mean shot plus miss, shots plus misses. And by Corsi, we mean shots plus misses plus blocks. And so it turns out Fenwick and Corsi are kind of good indicators of team performance and player performance, which I don't know. At first, I thought this was kind of surprising. I was really skeptical of that because I look at that and I see shot plus miss. Well, how can you count misses the same as shots? And how can you even count misses as being good? You miss the net. All right. So I'm sure many of you have, if you're a hockey fan, you watched the 24/7 series on HBO this winter. And one of my favorite parts about the series was getting a peek inside the locker room during, what do the coaches say to the players during intermission? And it's pretty much like the locker rooms that I've been in. The level of play of hockey was probably slightly higher than the locker rooms that I've been in, but it's what the coaches say. I mean, it's pretty similar. But here's one thing I didn't hear said during the 24/7 series. And after this reenactment, I think you'll understand why I do math and statistics, and I'm not a coach or an actor or a motivational speaker. So here goes. All right. These are the bad jokes I was talking about that some people have heard already. So maybe different people will laugh this time. Thank you. All right. Hey, that was a great second period. We pulled within one, and we did it because of hard work. Each and every one of you in this room outworked the players that you were playing. If we do that again in the third period, we're going to win this game. The one thing that we need to change is we need more missed shots. Our Fenwick rating is not high enough. We need to miss the net more, and we need to get more of our shots blocked. All right? There it is. Okay, so no one's going to say that because it's not that missed shots are good or that blocked shots are good, but these things are an indication of two things. They're an indication that, first of all, you had possession of the puck, so it's kind of an indication of possession time. It's also an indication of zone time. So typically, when you take a shot or you have a missed shot or a blocked shot, you're in the offensive zone. So it's an indication of these two things. All right, so it's not that these are good or the goal that the goal should be get as many missed shots as possible, but they are indicating something that is good. And so if we go back to our correlations and we take a team's Fenwick, just offensive Fenwick rating in one half of the season and look at goals in the second half, or do the same thing with Corsi in one half of the season and goals in the other half of the season, we get a little bit better. It's still not that much better. We get a little bit better. I think the differences in these numbers would be higher if we used smaller chunks of games. But I think because we're using a half season's worth of games, it's not too much higher. Some other people have gotten that there's a larger gap between shots in Fenwick or shots in Corsi. Here it's about the same, but. So these things are good indicators of performance. And the weightings are easy to remember. You know, shots plus miss plus blocks, they're all weighted the same. They all have a weighting of 1. It's 1 times shots plus 1 times miss plus 1 times block. But the weighting's probably not optimal. So Corsi has got all weightings of 1. What about, how do we know it's not, how do we know that shots shouldn't be weighted with a 2? It seems like shots are better than misses and blocks, so maybe that should have a higher rating. Maybe blocks should have a rating of 0.5. Or maybe there's some other A, B, and C that is best in some sense. And so this is one goal that we could do, is we could find the best optimal rating of the optimal A, B, and C. And so we can do that in a variety of ways. We chose ordinary least squares and ridge regression for 2 ways that we did that, but there's countless other ways that you could try to find the optimal A, B, and C. So that's one thing we could do. The other thing we could do is why not include more variables other than shots, misses, and blocks. So here's the other variables that we included. We looked at goals. We looked at zone starts. So how many times do you start shifts in the offensive zone with face-offs in the offensive zone, neutral zone, defensive zone? We included turnovers, giveaways, and takeaways. We included face-off wins, losses, net face-off wins, face-off winning percentage, all that stuff listed there. Hits and hits against, and shooting percentage. And after the model selection process, we dwindled it down to 4 variables that turned out to be significant: goals, shots, net hits, and total face-offs. So goals and shots probably aren't that surprising. Those seem like good things. Net hits, by that I mean hits against minus hits. So this was a little surprising because it had a positive coefficient, indicating that high hits against is a good indicator of goal scoring, and low hits is a good indicator of goal scoring, which maybe seems counterintuitive because it kind of sounds like I'm saying hits are bad and hits against are good. Like what we really need to do this third period is make sure we get hit as many times as possible. No coach is going to say that, right? But I think these are indication of possession also. If you get hit, that means you had the puck, or you just had the puck, or maybe you currently have the puck. If you hit someone else, it means the other team has the puck. Otherwise, it's an illegal hit. All right? So I think that's why this is becoming significant. I have 3 reasons why I think total face-offs come up as significant, but I'm going to postpone that. If you want to talk about it, you can come to my poster and we can talk about it there, but I'm not going to spend, I want to get through the rest of the presentation, so I'm not going to spend time on that. All right? Sounds like a cop-out, but but I'll show a graph later where we didn't use total face-offs and the model is still good. So here's what we had before. What if we take Corsi, which is shots, misses, and blocks, and we add hits against and subtract hits? You do a little bit better. All right. So what if we take the optimal weightings using goals, shots, net hits, and total face-offs? You do even better. And so that's with ordinary least squares regression, and there's with ridge regression. It's almost the same. So it turned out that using ridge regression wasn't really helping. These come out to be the same. So this is saying using the optimal weights of goals, shots, nets, hits, and face-offs in one half of the season and goals in the second half of the season, the correlation is 0.52, which still isn't super high, but it's better. I mean, our target is very random. Goal scoring rates are very random, so okay. So I'm going to skip that one and move on to, so how can we use this thing, first of all? So we could use it to evaluate team performance. So we're talking about, this is like expected goals. The results of this model can be considered expected goals. So we could imagine some standings that have goals for, or wins, losses, points, overtimes, losses, whatever. Goals for, goals against, net goals, goal differential, or whatever you want to call it. But also expected goals against, expected goal differential. So we could do that. There's various things that you can do for teams. I'm going to focus on what can you do for players. And one of the things that you could do for players is come up with like a plus-minus statistic using expected goals instead of goals. But we also want to adjust this thing for various things, for various reasons. So why is the plus-minus statistic not that good? Well, it depends on the strength of your teammates, depends on the strength of your opponents, depends where you start your shifts. If you're always starting your shifts in the defensive zone and you're always playing the opposition's best offensive players, your plus-minus is going to tend to be reduced a little bit because of that. So we want to adjust for all those things. So one way to adjust for teammates is the following. Let's take this example. This says Crosby's goals for per 60 minutes is 3.54, and this is over the last 4 full NHL seasons, all right, 2007 to 2011. His teammates scored 2.51 goals per 60 minutes. And so the difference between those two could be considered Crosby's contribution to his team. This is how much the scoring rate of his team goes up when he's on the ice. It goes up by 1.03 goals. And that turns out to be the best in the league. So this is one way to adjust for strength of teammates. You could do this similar thing for strength of opponents also. And you can do similar things for zone starts. And these kinds of things have been done by various people. There's a whole list of them there, and I have all the references. I don't have time to go into the details of all of these, but all of these folks have done something similar to what I just showed, maybe slightly different, but something similar. And some of them have used things other than goals, like shots, Fenwick, and Corsi. Like I know Gabe Desjardins uses Fenwick and Corsi a lot, adjusted for strength of teammates. You can also use expected goals, the thing that we've talked about in this talk. All right, another thing you can do is do a regression-based adjusted plus-minus. So if you're familiar with the basketball analytics crowd, this is the one that was more common and was created first in basketball. It's the regression-based adjusted plus-minus. It's almost the same thing with a couple adaptations for hockey. But this adjusts for strength of teammates, opponents, and zone starts, 3 of the things that we talked about. And and here's some of the basketball references and a couple of the hockey references. So you can use ordinary least squares regression, which was the first one used in basketball. 2 years ago and at the Sloan Conference, Joe Sill for basketball used ridge regression and showed that it was an improvement over ordinary least squares regression. And so that's ridge regression is the one that we're going to talk about here. All right? And we can use many stats with this adjusted plus minus, this regression-based adjusted plus minus. We can use expected goals, or we can use goals, shots, Fenwick, Corsi, expected goals. We could use weighted shots using shot quality. We could use any of those statistics. And so that's what we've done here. And so here are the top 10 offensive players according to adjusted plus minus using these various statistics. So at the top we see Sidney Crosby is, not surprisingly, the best offensive player according to expected goals, according to goals. He's actually second in weighted shots. And all the other players on this list are pretty much regarded as the best offensive players in the league. There might be a couple omissions there. You might disagree, but I mean, this is a pretty good list of the top offensive players in the league. And I should mention that the units of these things are goals per season on the left, goals per 60 minutes on the right. The two columns on the right are goals per 60 minutes. So Crosby actually leads the league despite the fact that he missed a lot of time in the past couple years. So he missed all this time, but he's still actually the top player in the league on offense. But what about defense? Okay, so according to every version of adjusted plus minus, Pavel Datsyuk is the best defensive player in the league. Or I should say best defensive forward in the league. This is only forwards. So according to expected goals, weighted shots, Fenwick, and Corsi, Pavel Datsyuk is the best player, best defensive player. And if you notice, he was on the top 10 list of best offensive players. So that means if we take overall play, offense plus defense, he's the best player in the league, according to adjusted plus minus. And I saw a poll of a bunch of players, and I saw that Pavel Datsyuk came out on top in like 6 different categories where the players voted on who's the hardest to play against, stuff like this. So I guess the players agree with adjusted plus minus. I believe my time is just about up, and I think there is a bunch of references, and so we'll get to questions. I mean, there's tons of references there. I wasn't going to talk about it. It's more for future reference when you look at the slides on the website or something like that. Question? I think they're asking you to use the microphone.
I may have missed it because I came in slightly late, and I apologize, but does your ridge regression specifically account for repeated measures on players, teams, perhaps by using random effects?
It does not use random effects, no.
Do you think that may influence the variability around players that you observe?
Possibly. What random effects would you include?
Well, you could include player, game, team, for example, because if you have random effects in there, you can what would be the word? You are less likely to violate the assumption of independence that you get when you treat everyone just the same.
Okay. It's possible that could be an improvement, but I haven't tried that yet. Yeah.
There's an endogenous relationship between score of the game and whether the team is going to score another goal, right? So if you're up 3 goals or up 2 goals, you have a different incentive to play offense compared if you're down 2 goals.
Yeah.
Have you considered incorporating that in the model? Because some teams who are, trailing or leading often based on the quality, players on those teams are always in a different state of the game.
True. So I have considered it, but I have not done it yet.
Right.
But I mean, I guess the next time that I update this, that will be one of the things that I update it with. That'll be an additional variable, additional independent variable in the model, or including it. Maybe there's some other way to include it that would be better than including it as an additional variable. But it is something that should be included. Another thing is initial So we include zone starts. Do you start a lot of your shifts in the offensive zone? You could also include initial possession. Do you start the shift with possession of the puck? Like,
Goals are probably not systematic in the game.
yeah.
Right, as much as score of the game.
Right.
So you probably won't see a change in your ranking.
Yeah.
Try to score the game.
And as we heard during the hockey analytics talk, the hockey analytics panel, face-offs aren't that important, actually. So, yeah.
Have you considered modeling for back-to-back games and proving that production declines on the second game rather than the first game?
Actually, I have not thought of that, but
Yeah,
that would be interesting to look into. I can't recall seeing any study on that online or anything like that, or in any of the sports journals. So that would be something to look into.
If you play with the same line mates all the time, won't those measures you showed at the end be identical for your line mates? And if so, why don't we see more line mates appear in those evaluations?
Because with the exception of the Sedin twins, that doesn't happen enough for them to be really close to each other. The Sedin twins play about 93% of their shifts, 93% of their playing time is together. And you'll notice that, I got rid of it, but Daniel Sedin is on that list and Henrik isn't. But their ratings, I don't find them to be reliable at all. If you add in a little more data, they'll flip-flop places and stuff. So the regression has a difficult time separating the contribution of Daniel and Henrik because they're always on the ice together. And any model would have trouble doing that. So someone suggested, why don't you just consider them to be one person? And that's might not be a bad idea, actually, since they are identical twins. Anything else? All right, thank you.